Hi, my name is Professor Deb Stockbridge. This PowerPoint presentation is based on the 6th edition of Absolute C++ by Walter Savage, published in 2016 by Pearson Incorporated. This presentation is for the C++ programming class at Quincy College and anyone else who would like to learn about programming. In Chapter 4, you will learn about call by value and call by reference parameters. Another important topic is overloading. When a parameter is called by value, a copy of the value is passed to the function, and the function makes changes to the copy, but the original is not changed. Call by value is not practical when the value passed might be an array with 1,000 elements. It would take a lot of overhead to copy that array. In call by reference, the address of the parameter is passed to the function. The function can now make changes to the parameter value. To prevent the changes from taking place, you can place const in front of the call by reference parameter, and it now cannot be changed. So note the example that's at the bottom of the slide. The name of this function is AMT. It's a void function. It doesn't return anything. And it has two parameters, price, and it gives it the address of price, and price is an integer. And this const makes sure that it's given the address of price, but it can't be changed. And the same thing is true with number. It's given the address of number, but the const makes sure that it can't be changed. In this slide, it shows what not to do. So on the left, we have a function definition, and the name of the function is min, and it has two parameters, both integers. And when they are used in the header, that's the same thing as defining them. So you don't need to redefine them in the executable statement or in the body of the header. So you don't want to say int A and int B again. You don't need that. We would just say int min, and then we have if A is less than B, A is assigned to min, else B is assigned to min. And the min function is returning an integer, so that's why we have return min, goes back to the main program. So this slide gives an example of why you might want to have your function change values. The name of this function is swap, and basically what it's going to do is it's going to put whatever is stored in num2 and store that in num1, and then whatever stored in num1, they're going to store it in num2. Now, in order to do that, they need to have another variable, and that's why we introduced extra. So first, we have num1 is assigned to extra, and then num2 is assigned to num1, and then it takes what was stored in extra and assigns that to num2. So you can think of another example why you'd need to have a third variable. If you had a cup of red dye and you had another cup of blue dye, and you wanted to put the blue dye in the red cup with the red, make it in the red cup, and then in the second cup you want that to be the red. In order to do that, you'd have to have another cup. Otherwise, as soon as you put the blue into the red cup, you'd end up with purple. The designers of the C++ language are always trying to make it easier for programmers. So one of the things they came up with is overloading. And that allows you to use the same name for different functions as long as they do something similar, and they have to have different parameters. So one difference, they could have two doubles, or you have a double and an integer, or it could have three integers. And they could all have the same name, and when the function is called, the compiler looks to match the arguments with the correct function. So for overloading, functions have similar instructions and they all use the same name. Each function must have different parameters, such as a different number of parameters or different data type of the parameters. And the compiler will match the function parameters with the correct calling function. So over on the right, we have one function called max, which receives 3 integers and returns an integer. We have one max with 2 doubles, and we have a max with an int and a double. So with the function calls, the first one has max and it has 2 doubles, so it would go to that second function listed above. The next one has 3 integers, that would go with the first one, and the last one has an integer and a double, and that would go with the third definition. When a function call is looking for the overloaded function that matches that call, it first looks for the exact signature. So if the function call has 2 integer arguments, the function call looks for the function that has 2 integers as parameters. If it does not find one, it looks for one that is compatible. So let's say a function is looking for an overloaded function with 2 doubles, and the function call arguments are 2 integers. So what the compiler does is it makes the integers into doubles by just adding the decimal point and a 0. So no data is lost at all. But look at the last sentence here. We have to be careful. If the function parameter is an integer and the call passes a double, the compiler will make the double into an integer, and that data with the decimal point after is lost. Sometimes it's useful to supply default values for the parameters in a function. If the user does not supply all of the values, the default values are used. Note that if there are 3 parameters in a function, all of them could have default values, or the second and third could have default values, or just the third could have a default value. You cannot have just the first parameter as a default value and not have default values for the second and third parameters. There are various testing and debugging functions which can be used to test your program. Cout statements can be used to test functions and trace the execution of a program. The assert macro is used to determine if something is true or false. It is used for checking preconditions as well as postconditions. So in this example, we use the word assert, and then you have your condition. If balance is less than withdrawal. And this could be in a program that allows a customer to withdraw from their account. If balance is less than withdrawal, if that's true, the program ends. When you're using assert with the condition, you have to include a preprocessing directive of pound include, and then in the arrows, cassert.